Picture this. You're sitting in the exam hall. You're staring down a 6-mark question on data integrity. The clock is literally ticking down. Now, this right here, this is the exact moment where your grade boundary gets decided. And here's the crazy part. It's not decided by what you memorized. No, it's decided by how exactly you write it down on that page. So, let's test this right now. A data transmission error occurs in a banking system. You start writing your answer. What loses you the most marks? Is it A, providing the wrong definition, B, forgetting the context, or C, confusing your terminology? I want you to lock in your answer mentally right now. Go on, pick one. A, B, or C? Because the harsh reality of the IGCSE 0478 exam is that top-tier candidates, students who really know their stuff, fail to secure maximum marks all the time. And it's not because they don't know the tech, it's because they fall into one massive, entirely predictable trap. The truth is, there's a singular examiner clue, a highly specific way of structuring your response that makes the answer to that poll we just did incredibly obvious. It's literally the difference between just scraping by with a passing grade and comfortably securing a top band. We're going to completely decode that clue today. Okay, so let's get into it. To build up to that high mark strategy, we've got to start with concept compression. See, things like checksums and check digits, they can't just be taught as isolated facts you blindly memorize. You have to ask yourself, what actual, real-world digital problem do they solve? Think about it. A checksum, well, that's a calculated value used to ensure data integrity during transmission, like when you're sending a giant file over a network. A check digit, on the other hand, is a form of validation. It's usually just an extra number slapped onto the end of a string, like a barcode on a snack or an ISBN on a book. And its whole job is to spot data entry errors. When you actually understand that these methods are solving specific, tangible problems around data integrity and validation, the terminology stops being a list of words. It becomes meaningful. You're no longer just memorizing flashcards. You're actively solving a digital scenario. But here's the thing. Our absolute biggest blind spots usually hide right in those theoretical foundations. Computer science mistakes pop up constantly when learners confuse related but very different concepts. I'm talking about mixing up memory and storage, or protocol and service, or validation and verification. If your revision notes aren't training you to compare these concepts just as much as explain them, you are leaving precious marks on the table. You absolutely have to know what a check digit is, and, maybe more importantly, exactly why it's not a checksum. So, how do we fix this? The crucial point is applying a rock-solid, disciplined technical methodology. You literally must follow this exact sequence in the exam hall. Step 1, identify the specific requirement of the task. Step 2, classify the relevant data, the hardware, or the algorithmic structure. Step 3, explain how the process works in a clear, logical sequence that another learner could easily follow. And Step 4, connect that explanation right back to the context. I mean, are they asking for causes, effects, advantages, or an evaluation? If you miss Step 4, your perfect, beautifully written technical explanation just lost half its marks. And to make absolutely sure you execute that methodology flawlessly every single time you sit down to write, we're going to rely on a very specific number: 4. Now, in just a moment, I'm going to reveal the exact examiner clue that completely changes how you answer, the secret sauce that guarantees those top band marks. But first, you absolutely need the framework that makes that clue obvious in the first place. Enter the 4 prompts. Prompt 1, what is it? Prompt 2, how does it work? Prompt 3, where is it used? And prompt 4, why use it over an alternative in that specific situation? Listen, if you can answer those 4 prompts out loud for checksums and check digits right now, your topic is fully ready for the exam. But if you stumble on prompt 4, well, you're vulnerable. Which brings us right to the ultimate examiner clue. Think back to that opening poll. The reason students lose the most marks? The answer is B, forgetting context. The ultimate examiner clue is specificity. Top band examiner style performance depends entirely on it. Generic responses almost never gain full marks. Look, if the context in the question is a school, or an office network, or an industrial robot, or a security incident, your answer has to stay locked inside that context. Students constantly know the theory inside out, but they bleed marks because they absolutely refuse to anchor their explanation to the scenario on the page. Let's actually see how this plays out in a real exam answer. A flawed, totally generic response might just say, it checks for errors. Okay, maybe that gets you 1 pity mark if the examiner is feeling generous. Now, check out the top band answer. The check digit validates the school database entry upon input by recalculating the final digit to ensure no transcription errors occur during manual entry. Bam, 4 marks. Do you see the difference there? The top band answers specifically uses the word validates. It directly names the school database from the prompt. It specifies that this happens upon input, and it identifies transcription errors. It is brilliantly, suffocatingly specific. All right, let's do a quick interactive challenge. Imagine the exam question asks you to explain how a checksum ensures data integrity for instructions sent to an industrial robot arm. So you write this beautiful, flowing explanation about how a checksum verifies that the items in a website shopping cart haven't been corrupted. Okay, what went wrong there? Well, you totally abandon the context. It doesn't matter how well you explain the shopping cart. The question asked about a robot arm. This happens so often that examiner reports constantly flag it. They say things like, common errors come from vague wording, missing process steps, or failure to answer in the context of the question. You see, naming a device without explaining how it works, or throwing out an advantage with zero reasoning to back it up, absolutely destroys your grade. You can't just describe a piece of tech that sounds kind of related. You have to explain the exact sequence of how it works, directly applied to whatever prompt they've given you. Because of that, before your pen even touches the paper in the exam, you need a mental checkpoint. You must diagnose the exact demand of the question. Ask yourself, is it asking for a process explanation, a hardware selection, some binary manipulation, or maybe protocol understanding? Once you diagnose that demand correctly, you are way less likely to panic and just brain dump everything you know without any direction. Instead, you're aiming your knowledge directly at the target. A really fantastic way to lock this mindset in is through real-world transfer. Think about it. The exact same data integrity patterns we study appear out in the wild, in smartphones, online banking, robotics, retail systems, and secure comms. When you show these links in your mind, it helps you remember not just the name of the concept, but the actual consequences of choosing one method over another, right? If a banking system drops a data packet, financial records get corrupted. That's huge. If an industrial robot arm receives a corrupted coordinate, it could cause physical damage on a factory floor. The stakes in those scenarios are entirely different, which means your exam justification for them cannot be copy-pasted. It has to be customized. To reach this level of exam mastery, you need a layered style of studying. I highly recommend what we called the 3-pass revision cycle. Pass 1 is all about securing your key definitions and contrasts, really cementing the difference between validation and verification. Pass 2 is where you rehearse worked explanations and code-like structures out loud, literally speak them into the room. And Pass 3, that's mastering exam adaptability. That means taking a practice question, changing the scenario entirely, mixing in similar terms, and forcing yourself to justify your choices all over again. This layered style is absolutely vital because IGCSE questions love to combine theory with applied reasoning. So, look at where we are now. You've got the framework, checksums and check digits, officially mastered. You know to use the 4 prompts, you understand the absolute necessity of specificity, and you know exactly how to anchor your answers to the context. But here is the massive, totally unresolved problem currently looming over your head. This topic we just covered, it's just one microscopic fraction of the entire Cambridge IGCSE 0478 syllabus. The rest of that syllabus is still a massive risk to your grade boundary if you don't step up and apply this exact same methodology to it. You simply cannot afford to apply generic, lazy revision to the rest of your computer science topics. You need to map this high-mark strategy across every single chapter, from logic gates all the way down to cybersecurity, before you walk into that exam hall. You need the exact step-by-step sequence to follow when your exam time is rapidly running out. To survive this exam and secure your top band, your absolutely mandatory next step is to get your hands on the full syllabus map. So click the explainer on screen right now to get the last 7 days revision map for Computer Science 0478. And make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. You've got the tools for checksums now, but honestly ask yourself, are you going to let a generic answer in some other chapter cost you your A star? Or are you ready to master the map? Click the explainer and I'll see you there.